Hello students, good morning. We will continue this exercise 16.4 after the question number 10. So see the explanation for the question number 12 first. Here in the question it is given we have the internal measurement of a cuboid with this length 10 centimeter, breadth 8 centimeter and height 7 centimeter. And we have to place some of the cubes with the edge 2 centimeter in that cuboid. So first see, if we place the cubes lengthwise, then see, first count here 1 2 3 4 5 cubes can be taken lengthwise. So as because length is given 10 centimeter and the age of the cube is 2 centimeter, so in that cuboid 5 cubes can be taken lengthwise. Now breadth wise you can see 8 centimeter is the breadth, so we can place 4 cubes breadthwise. But when we see height wise, then height is given 7 centimeter. So after taking 3 cube, we cannot take more than 3 cube, that is the fourth. We can't take that fourth cube, correct, as because the length is 7 centimeter, so 1 centimeter remains vacant. And the height up to which the cubes are placed is 6 centimeter. 2 plus 2 plus 2, 2 plus 2 plus 2, 6 centimeter, and 1 centimeter remains empty. So that's why we will consider the height of the cuboid as 6 centimeter, as because the 6 centimeter, the height up to 6 centimeter, the cubes are placed. So see here this line, if we equate the volumes, the number of cube is multiplied with the volume of each cube gives the total volume of the cuboid, correct. So as we know that volume of cube can be taken as the side cube or edge cube. So here a cube is the volume of the cube. You can see the last line, volume of the cube is a cube, and volume of the cuboid, volume of the cuboid is length into breadth into height. And here we have the new height h dash, which is 6 centimeter, after ignoring that one additional height, because the cubes are placed up to 6 centimeter of height, okay, and 1 centimeter is ignored. Now see the calculation here, the number of cube is multiplied with a cube. A cube means the volume of one cube is equal to L into B into H. This is the volume of the cuboid. So we have all those values. See, number of cube is equal to L into B into H dash divided by a cube. We have the length 10 into 8 is the breadth into 6 is the new height, and it is divided with 2 cube. So 2 cube 8, 8 cancelled. So 10 into 6 gives 60. So 60 is the answer. That is the number of cube that can be placed here in this cuboid. So by the same idea you can solve the question number 11. So try to solve the question number 11 by your own. I am going to the next question, question number 13. For the question number 13, we have the cost of a certain type of wood, and the cost is given 250 rupees 250 per meter cube, per meter per meter cube. So here for the volume 1 meter cube we have to pay that cost 250, and we have bought a particular cuboidal block, and for that we have paid 182.25 rupees. So as you can see here, it is 250 for 1 meter cube. So we have paid 182.25, so it must be less than 1 meter cube. That means whatever the cuboidal block that we have bought is must be of less than 1 meter cube, must be of volume less than 1 meter cube. And that's why we have converted this meter cube into centimeter cube. So here 1 meter cube can be taken as 10 to the power 6, that is 1 million meter cube. 6 zeros are there, correct. Therefore if we equate the rates, if we equate the cost, 250 for 10 to the power 6 centimeter cube, and we have paid 182.25 for a given volume of the block. So the volume of the block in centimeter cube we can calculate. See, the volume of the cuboidal block is equal to 182, after cross multiplying the terms, 182 into 10 to the power 6 divided by 250. So 182.25 into 10 to the power 6 divided by 250. If we solve those, we will get this 729,000 centimeter cube. If you want to convert this one centimeter cube into meter cube, then we'll divide this term with 6 zeros, 1 and 6 zeros, so that decimal will come here before 7, so it will be 0.729 meter cube. So this is the volume of the cuboidal block that we have bought. And we know that for the cube, a cube is the formula for the volume, so a cube is equal to, here we can take for the 729, it is 90 centimeter whole cube. So 90 is the side, so length of one side of the block is 90 centimeter. See the last line, it is 90 centimeter, and the 90 centimeter can also be written as 0.9 meter. Now I am going to the next question, that is question number 15. See the explanation part. If you see this explanation, you can solve the question number 14 also. So here we have a cuboidal container. See, this is the cuboidal container. The base of the container is a square with a side 6 centimeter. So see, this is the base, this is the base, and the base is a square with the side 6 centimeters. So we have the area of the base is 6 into 6, that is the area of the square. So 6 into 6 gives 36. And the volume of the empty space, it is given in the question that water is filled in the container up to a height such that above that level of water 1 centimeter of the container remain empty. So 1 centimeter of height remain empty, so the volume of that empty region, empty space, top empty space of the height 1 centimeter can be calculated. So we have the area of the base 6 into 6, and we have that height for that empty section is 1 centimeter. So 6 into 6 into 1 gives 36. So 36 centimeter cube is the volume of that empty space which is not filled with water. Correct. Now, as it is given in the question that a cube is placed in water, completely immersed in water. So this is the cube, this is placed in water, and when it is placed in water, the level of water go rise, it will rise up, and after rising up to that much of height, up to the top level, it will some amount, it will flow out, that means some amount of water is overflow. So here when the cube is placed, the volume of water that overflow, it is given 2 centimeter cube, that is the volume of water that overflow. As to calculate this cube, this volume of that cube, we know that when the cube is placed, first the water go rise up and cover that empty space. So whatever the volume of the empty space, we know that it is 36 centimeter cube. And after that, it will there will be some overflow of water also. So the quantity of water that overflow out is 2 centimeter cube. So actually when the cube is placed here, it will cover up to that much of space such that the water rises and cover that empty space, as well as it will some amount of water is also overflow. So here you can see the volume of the cube is equal to volume of the empty space plus volume of overflow water. So we have the volume of the empty space is 30 centimeter cube, and the quantity of water is overflow, the volume of water is overflow 2 centimeter cube. So the sum is 30 plus 2 is 36 plus 2 is 38 centimeter cube. So this 38 centimeter cube is the volume of that cube. When this cube is placed in water, that much the water will rises up, that means this cube will occupy that much of space, that 38 centimeter cube of space, and that's why the water is displaced up to 38 centimeter cube up to that empty region, and some amount is also overflow. Now go to the next, here question number 16. It is very easy question. We have two cubes, and those two cubes are of age 12 centimeter, correct, 12 centimeter, and we are joining those two cubes by their ends. So we have considered that lengthwise we have joined those two, so the length become 12 plus 12, and the other parameters like the breadth is 12 centimeter, remains 12 centimeter, and the height remains 12 centimeter. Now we have a cuboid, a newly formed cuboid. So for that cuboid, we have the length 24, we have the breadth 12, and we have the height 12. So in order to calculate the surface area, we have the formula 2 into length into breadth plus breadth into height plus height into length. So we have substituted all those values. See, all those values are substituted, and then after calculation is done here. So the answer, the surface area of the cuboid is 1440, that is 1440 centimeter square. Now I have skipped the two question, that is question number 17 and 18, and we have the solution for the question number 19 here. In the question number 19 we have a field, and the length of the field is given 30 and the breadth is 18. So we can calculate the area. See, area of the base of the field is 30 into 18, that is 540 meters square. Correct. Now as per the question, there is a dig. Okay, the pit is dug here, and this for that pit we have the length 6 meter and the breadth 4 meter. Correct. So that much of area is now not included here in this field, so we have to subtract that part from the field. So we have the area of the pit 6 into 4, which is 12 meter square. So this 24 meter square. So this 24 meter square is to be subtracted from the total area of the field, so that we can get the remaining base, the remaining area of the field. So remaining area of the field is 540 minus 24, that is 516 meter square. Correct. After the pit, after digging the pit, we have that much of remaining area of the for the field. 516 meter square is the remaining area for the field. Now go to the next page. Here we have the depth of the pit is given is 3 meter. Now if the depth is given 3 meter and we have the length and breadth, so we can calculate the volume of the pit, and the volume of the pit give the volume of the soil removed out from that pit. And that soil, see, first we have calculated the volume. So you can see here 6 into 4 into 3 is equal to 72 meter cube. It is the volume of the pit or the volume of the soil that removed out. Correct. Now according to question, that removed soil is spread over the remaining area of the field. The remaining area means 516 meter square. So in that area of 516 meter square, the soil is spread, and that's why there will be a rise in the level of the field. So we have to calculate that rise. Suppose we have taken that rise as h. So 516, that is the area of the base, the area of the field, it is multiplied with the height. So area into height gives the volume, and we know that the volume of the soil that spread over the ground is 72 meter cube. Correct. So 516, that is the area, is multiplied with the height up to which the level is rise, and it is equal to 72 meter cube. So we have h equal to 72 divided by 516, which gives 0.1395 meter, and as per the question we have to get the value in centimeter up to two significant figures. So it is the answer 13.95 centimeter. So this is the answer, and this is all for today. Thank you class.